Hello, hi, I'm Farah.
Hi, I'm Akira. Hi, I'm Nadia. Where are we? Lama Batik Upsi.
What are we here?
We are going to talk about chapter 6, which is Linux server deployment.
Okay, let's go. Okay, firstly, for this chapter, we need to understanding the server hardware. What is the server hardware? Although server are different from personal computer, there are many ways server hardware is different from desktop hardware. Both are made for the same basic component like power supply, memory and CPU. Server sometimes also employ redundant or hot swappable component. Sometimes desktop too might have hot swappable component. Such characteristics are much more common on server. There are three types of server hardware. Firstly, tower server, rack server and blade server. So in this video, we're gonna discuss about blade server. Although blade server are similar to the rack server in design, they are thinner and also cost more than the latter. Application the server blade are literally server on a card that contain processor, memory, integrated network controller and other output port.
So, the next topic is configuring server storage. Okay, so in this section, we will examine the configuration of advanced server technologies that are commonly used in Linux servers, including SCSI, RAID, and ZFS. So we are going to go through all three of them, starting with SCSI hard disk configuration. So SCSI, or the Small Computer System Interface, was designed as a way to connect multiple peripherals to the system in a scalable, high-speed manner. In most systems, a CSI device is connected to a controller card, which in turn connects all devices attached to it to the system, including parallel SCSI, serial attached SCSI, and ISCSI. So the first one, which is parallel SCSI configuration. Okay, so parallel SCSI, which is the traditional SCSI technology, relies on ribbon cables to transmit information between the hard disk and SCSI controller. These devices can attach to the SCSI controller card via one cable with several connectors for the devices to plug into. Okay, information is then sent from device to device along this cable in a daisy chain fashion. So, going through the configuration, before you install a Linux system, you must first ensure that you configure your parallel SCSI device properly. Okay, first, verify that all of your SCSI components, such as SCSI controller, cables, hard disk and terminators, support the same technology as listed in this table. Okay. Next, ensure that your SCSI components are connected properly as shown in this figure. Finally, make sure that your system recognizes the hard disk at system startup. To do this, examine the system BIOS or enter the SCSI BIOS on your SCSI controller card. Okay, so when you start the Linux installation, your SCSI hard disk will be detected automatically as shown in your screen. Okay, so next one is serial attached SCSI configuration. Okay, so serial attached SCSI is a new SCSI technology that can transfer data at up to 768 megabytes per second. Okay, so we go through the configuration. Before you install Linux on a system that includes serial attached SCSI hard disk, you must first connect the hard disk to the SCSI controller via the correct serial cable. Then you must ensure that the hard disks are detected properly by the system or SCSI BIOS. Okay, as with parallel SCSI disk, your Linux installation will detect your serial attached SCSI hard disk using, as you can see on your screen, and so on. So the third one is SCSI configuration. Okay, so Internet SCSI is a recent SCSI technology that uses network cables to transfer data to and from remote hard disks, either on the local network or across the internet. Okay, so the computer connected to a remote hard disk via ISCSI is referred to as an ICSI initiator, and the remote hard disk is called as the ISCSI target. So the configuration settings for remote ISCSI devices vary by manufacturer. To connect Linux computer to the remote ICSI device, you must specify the configuration settings while installing Linux. This means that you must understand the configuration settings used by your ISCSI device, which is name, authentication information, etc., and ensure that your computer has an ISCSI compliant network card before starting the installation process. During the Linux installation, you need to provide the details regarding your ISCSI target if you want to install Linux on an ISCSI device. Following this, the installation will proceed and allow you to create a Linux file system. For example, as you can see on your screen, on your ISCSI devices.
Okay, next we're gonna discuss about RAID configuration. RAID configuration recall that you typically create several partitions during installation to decrease the likelihood that failure of the system on one partition will affect the rest of system. Those partitions should across several different hard disks to minimize the impact of the hard disk failure. If one hard disk fails, the data on the other hard disk is unaffected. If a hard disk failure occurs, you must power down your computer, replace the failure hard disk drive, power on the computer, restore the data that was originally in hard disk drive from backup source such as type device. Currently, 7 basic RAID configuration ranging from level 0 to level 6 are available. Unlike hardware or firmware RAID, software RAID is configured entirely during the installation process, provided that your system has more than one hard disk. To configure software RAID during a Fedora installation, ensure that multiple disks are present and selected on your screen. Thank you.
Okay, now I will talk about the ZFS configuration. ZFS configuration is a zettabyte file system. ZFS is the high-performance file system and value management software that was designed for the largest scale Linux system that need to store on the data, multi-disk and SANs and remote system. Okay. The ZFS system detects and repairs all the errors automatic as data read and written, as well as protect against problem. Okay. It also supports new storage technologies such as PCI, SSDs, and the battery back RAM disk. Device with ultra low latency. ZFS is the primarily used on the largest Linux system that may have hundreds or thousands of the storage device. Here is the command for the ZFS pool to use. Okay. Firstly, to create a simple ZFS pool called data storage 1 from the second SATA hard disk, you can type. Second, to create a new ZFS volume called data storage 1 and mount it to the data storage 1, you need to type. Third, you also can use the zpool command to view the details for your data storage 1 volume. To create a ZFS pool and mirror ZFS volume called data storage 3, you need to type this here. Okay. To view the status of the hard disk that are part of the data storage 3 pool, you can use the following commands. To see the output of the zpool status data storage 3, you should to create ZFS pool REDHAT volume called data storage 4, you need to view the state and the performance of the ZF volume using zpool status and zpool IO start V commands. You need to create a directory under the data storage 4 called research. You need type. Next, to see a list of the ZFS file system and sub file system that are available for the FS management, you should lastly, to list the specific configuration parameters you can modify for your research sub file system, and you can see.
So now, I will talk about dealing with problems during installation. So guys, even after a successful Linux installation, problem might be arise if the installation program failed to detect the computer hardware properly, or if certain programs were not installed as expected. To ensure no such problem occurred, check the installation log files after installation and then verify system settings to ensure that all hardware was detected with the correct values. The installation log files are files that are created by the installation program that record the event that occurred during the installation process, including errors. For Fedora Linux, these log files are stored in the var log and kernel directory, and for Ubuntu Server Linux, these log files are stored in var log installer directory. To search this file for errors and warnings, you should use the grep command, as their content are often quite lengthy. For example, the egrep-i error warn var log anaconda. For example, can be used to search for any errors or warning within log files in the var log anaconda directory. To verify hardware safety, you can examine the content of the proc directory or boot up log files. So guys, the /proc directory mounted to a special file system contained within RAM that lists system information made available by the Linux kernel. Because this is an administrative file system, all files within are readable only by the root user. The following sample listing of the proc directory show many files and subdirectory contents. The subdirectories that start with a number in the preceding output are used to display process information. Other directories can contain kernel parameters. The files listed in the preceding output are text representation of various parts of the Linux system that are updated regularly by the Linux kernel and can be viewed using standard text commands, such as cat or less. To view the information that Linux has detected regarding a computer's CPUs, view the contents of the CPU's info file in the procs directory. Type. The preceding output is from a computer with one processor that runs at 2.4 GHz, processors O with 6 MB of processor cache. If this information is incorrect because Linux failed to detect the processor information properly, you might need to change a setting in BIOS or research a solution to the problem on the main board or processor manufacturer website. After installation, you also need to ensure that Linux has detected the correct amount of RAM, random access memory. to the disk, you can view the contents of the probe mem info file as shown in the following. In the preceding output, the total amount of memory mem total is 2044524 KB or approximately 2 GB. If this value is incorrect, you may need to change a setting in BIOS or research a solution to the problem on the mainboard or RAM manufacturer website. In some cases, it's necessary to insert a device driver into the Linux kernel as a module. This is typically true is specialized server hardware, such as Sun controller cards. To see a list of modules currently inserted into the Linux kernel, view the probe modules file as shown in the following output. To view the hardware detected during the boot time, you can use the dmesg or dmesg command after system startup, as shown in the following output. You can also view the system processes that started successfully or unsuccessfully during boot time by viewing the contents of the var log boot log file on most Linux distributions. A simple boot log file from an Ubuntu server system is shown in the following output. The general ctl command will display entries for each boot process. It is important to narrow down the time frame. The following command only display boot information from the current day. Roxanne.
Now I will continue about system rescue. Boosting to a live Linux OS from the live installation media offer several benefits to the Linux administrator when repairing and damaged Linux system. Can use the utilities on the live OS to fix the problem within a Linux installation on the hard disk. They are preventing a Linux installation boosting, such as both loaded problem, system file and partition problems, configuration file problems, and driver problems.
Hardware. What is server hardware?
Files and subdirectory contents.
That are commonly used on Linux servers, including SCSI. I'm sorry. Betul lah kan? Astagfirullah.
So now, I will talk about dealing with problem during
Card via one cable with several connectors for the devices to plug into. Information is then sent from device to device along this cable in a daisy chain fashion. Oh my god!